So, good evening, all. We welcome you all for this expert talk by Ajay and Srinivasamurthy. So, to give a brief intro, Ajay is an applied science manager with Amazon Artificial General Intelligence team in Bangalore, where he works on large-scale automatic speech recognition systems for Alexa. He's also an adjunct member of the faculty Department of Heritage Science and Technology, Indian Institute of Technology, Hyderabad. He's got his PhD in music technology from University at Kanpur, Spain, where he was a part of the Comp Music project led by Professor Xavier Serra, and also worked on several automatic rhythm analysis problems in Indian art music. And he has a diverse research interest and experience in the areas of speech, audio, and music signal processing and machine learning. So I welcome Ajay to this talk, and thank you for accepting our invitation. And I hope it will be very fruitful for all the audience. So over to you, Ajay.
Thank you so much, Param, for the introduction. So thank you for inviting me to this to speak about some of my thoughts around this. So this is going to be an interactive session largely, wherein I think this was pointed out that how do we actually build a research career in machine learning in the industry, given everything we have. And then I'm briefly going to talk about these four aspects. One is like topics. What are the topics that are going on? I mean, getting a lot of attention. And trends, how are we moving? What tools and workflows do we use? And tailwinds. Tailwinds are essentially the set of things that are pushing the machine learning work in the industry forward. And as a part of that, I'll be talking about several things as well. So as you see, I mean, this is like a short agenda for the next 40 minutes or so of the talk, right? I've started some show of hands to understand what's the background of everyone here, and then try and understand, kind of start from very basics here to understand why do we need machine learning, and that these context will help us to understand how we approach machine learning from an industry perspective, right? And then talk about some bit of evolution of ML, how, but a very abstract level, just to understand what are the things that we kind of mainly focus on, right? And then mainly talk about some challenges and opportunities in the industry and in India specifically, industry in India, not solving problems for India, right? And briefly talk about ML workflows, machine learning workflows that we use in the industry, and compare that with, say, typically what we are more familiar with in academia, mainly to kind of bring about just that contrast between how we approach things. And then, of course, these kind of, what do you say, these boundaries are no longer very like set in stone, so they are quite blurred now. I mean, that's a good thing. Yeah, so it brings in a lot of collaboration. Let's see how to do that. Then finally talk about some topics and trends. And finally, I mean, I'll sort of briefly touch upon how to prepare for the industry if you want to kind of looking for a career in machine learning in the industry, right? So and then there is an open Q&A wherein you can ask me anything, right? I mean, so again, a lot of this is going to be very interactive. So please stop me in case something is not clear. We can have a clear discussion and then move forward. And none of these are like objective in any sense. So let's try to understand like who's in the audience, and then I think it might be easier. Of course, show of hands works way more better when we are actually in a room. But then I do see largely, Param, you could probably confirm here in terms of the audience expected. So it's mostly people who are already ML practitioners who are working on machine learning already.
Probably, but I think you can go with show of hands because
Okay.
we posted at various LinkedIn also, so we could have a diverse audience also. So you can quickly.
That's perfect. So let's do the reverse in that case. So it's much easier on Zoom. How many of you have no experience with machine learning in this audience? Just use this raise hand feature, I think, which kind of gives me some idea.
Parampit, you can make Ajay a co-host or something, then he can also use poll option.
Oh,
Yes,
is that
sir.
so?
That should be better.
I've never used it actually. So how do you know how to do that? Okay,
On the rightmost, there is a polls/quizzes option. The three dots and
if I go to mode, is it in the apps or
no, it is. I'm creating one SP/ML.
space HTML, NLP, speech, MIR maybe, and then computer vision. So these are 4 areas, and then just want to understand if there are participants who are doing their bachelor's, master's, and PhD.
Just a moment. I will just write down here SP/ML and NLP and MIR.
Yeah, there will mainly 3 questions if you really see. One, I just want to understand the machine learning experience. So our participants, they have a machine learning background or not? Secondly, if yes, then do they work on any of these 4 fields, NLP, speech, MIR, and computer vision? And then the third question is like, are you a bachelor's student or a master's student or a PhD scholar?
Degree enrolled. Okay, it's done. Somebody can.
Okay.
Yeah, it's called untitled. Oh, launch. Okay, launch.
Right. Once it's launched, we'll probably take a minute just to kind of just answer this. And
Yeah,
then we can
the poll is
keep on.
live.
Okay, I do see the poll. Yes.
I think you can see the responses of poll, Ajay.
Yeah, I can see.
Yeah.
Yes. Yeah. Thank you.
Sure.
Okay, I can take the 70% participation and then continue not to kind of linger on this. Right. I do see, just to summarize, I see a good mix of bachelor's, master's, and PhD. Largely PhDs, half of them are PhDs, PhD students enrolled. And mostly everyone has some bit of experience with signal processing and machine learning. And a lot of them are working with computer vision, and then a good diverse set of people on NLP, MIR, and speech. So thank you so much. This is very useful information. Yeah. Okay, let's continue here. Right. I mean, so again, just before even I start, this is going to be a very personal talk. I'm not going to be discussing something. I mean, so there'll be a lot of subjective opinions here. So most of these opinions are personal. So nothing to do with Amazon also, and then nothing to do with what I mean. So what's out there? There is probably a lot of others who can also give you similar information as well. And in general, I'm not going to talk about what artificial intelligence or artificial general intelligence is, because that's not very well defined yet. And then I'm just going to limit to whatever tasks that we solve currently in the industry, right? So which is mostly with statistical learning, right? So the statistical learning eventually is being called as machine learning in a lot of contexts. I mean, and also artificial intelligence. I would want to kind of distinguish that, and then stick to statistical learning as much as possible, right? And then, of course, whatever we can cover in this we talk is going to be extremely non-comprehensive, just scratching the surface, right? And then it's not at all comprehensive in any way. So because it's a very rapidly evolving field, and as you guys know already, yeah, right? So this is just kind of to start up. Right. So let's start from the fundamental question, right? So why do we even need machine learning in the first place? So that will tell us what solutions will require machine learning based solutions, right? I mean, what kind of problems do we want to solve through machine learning, right? So if we kind of want to understand why and when machine learning is needed, it's typically needed in some of these 3 or 4 situations. Of course, I mean, I think so. You do see machine learning being applied in a wide variety of applications, but then you could, if you closely observe, it involves these few applications, a few kind of characteristics of the problem, where because of which machine learning is being applied there. Right? One is actually when there is real world and complex data involved that we want to model and then understand and then get insights out of that. And then typically that happens when we have a lot of data being collected from the real world, and then we do not have a very easy way to model them through analytical means. Right? Second one is no grammars or analytical solutions. There is no physical phenomena that has been nicely modeled using analytical solutions that we could kind of use. Right. I mean, there used to be lots of weather models which used to fairly work, which used to work fairly well. But that could be augmented through machine learning based solutions. So analytical solutions, when they are not working very well, then it could be augmented through data driven solutions, right? Which is what machine learning is. Then the third this is the main reason why machine learning is necessary in a lot of applications. It's the statistical variability in the underlying phenomenon. So take the example of speech. This the same sentence, sun rises in the east. If I say this 100 times, each time it is going to look different, and then it's going to have different signal characteristics, and then it's going to have different rate at which I'm speaking. Unless, I mean, most humans, when they speak, they have a lot of variability in terms of how they kind of speak. The same, even if the same content is the same. But of course, if you add the variability across languages, variability across like gender, age, and then the noise that kind of is in the room, and then several other things, then there's a lot of variability that gets created when the speech that gets generated. So that's why we need some form of like a model that is derived directly from data rather than kind of modeling rules, because it's not possible to cover all rules that can exist. Similarly, you can extend that to language. So in language, just means speech is one form of language expression. There's also writing, right? And then there is also sign language, and then there are other forms of language, right? In all of those as well, it's the same idea, right? Wherein we are trying to kind of express this complex thoughts, and then they could be expressed in so many different ways that there is a lot of variability in the data underlying phenomena. And that's how we can use that to kind of build machine learning systems to understand and analyze them. Same with images. There's a lot of variability in images as well. And these are like, what's say, naturally occurring signals, or to say speech language, meaning in images. Stock market is something human created. The data from there has a lot of variability again, because human behavior is hard to model. And when it involves a large number of people, it's even harder to be modeled, right? The last one, I mean, the last as in one other place where machine learning is necessary and could be applied is when there are large amounts of data beyond collective human interpretation. So the amount of data that we have to analyze is beyond what human beings could consume and then infer useful insights out of it, right? So take example of YouTube, for example. The amount of data that exists on YouTube, there is no way even a set of human beings could actually listen to all of them and then start kind of abstracting out and then providing us useful information to work on, right? So it's not possible for us to do that. So that's when I think machine learning systems can come and then kind of pitch in with specific tasks. So this is the case with music, stock market, same thing, sensor data. There are so many sensors out there, and then so it's very hard for humans to analyze that. So that's why we kind of need machine learning to be done through. I mean, we need computer systems, and then computer systems that use machine learning are the most efficient, the best suited for these kind of applications, right? So why am I talking about this here? So this is because these are specific cases in the industry as well, where we want to apply machine learning, and then we don't want to apply it everywhere, but then these are some clear places where machine learning is applied, right? So next, let's try and see kind of where we are currently in terms of machine learning that requires, and then that kind of tells a lot about what are the challenges that we face and then solve in the industry, right? So long term, well, initially, right, when we started out with rule-based analytical systems, wherein you had an input signal or a space, right? Input space, which talks about some kind of input data, for example, or input signal. And then we had rules and analytical formulae that would convert input signal and space to a particular output label or a space, right? So the rules could be, so I mean, it's that this kind of, and then the rules would be decided based on a human expertise. So say imagine a committee sitting and then kind of deciding on a particular cutoff for a particular entrance exam, right? So that's like a clear rule-based analytical system. So you have a particular input that is, say, how much is the score in some set of subjects. Then there is a formula which says this is the cutoff, and then that is decided by a committee of humans, for example. And then there is a clear mapping that goes to an output space saying admitted or not admitted, for example, things like that, right? So you see this everywhere. This is not that we have evolved out of this. This is in place everywhere. But then this is not the best use of machine learning machinery that we have, right? This is the way kind of a lot of current systems to operate, right? So the next in that is where we kind of started building data-driven expert systems. So here there is no data. The data is not used to make a decision, though we would still say the data over a period of years and then other things have kind of influenced the human experts themselves. But then we don't have a very easy way to model that, and then we don't model that explicitly here, right? What happened after that is, of course, then we said, okay, then like let's make this data-driven. So when do we do data driven? When we have any of these four different or 3 or 4 different ways of how the underlying phenomena is behaving, right? We have statistical variability. There are no analytical solutions. There's a lot of real world data, large amounts of data beyond comprehension, right? So that's when what initially the approach was to kind of take the input signal or space, extract some meaningful features out of that, which we think is relevant. Right. And then that involved a lot of human expertise to understand and arrive at features. Then we would also define a function mapper. I'm just using the name of function mapper here to kind of talk about any kind of system that could take one space and then map it to another space, right? So that's a function mapper. The function mapper would also be trained here in this case. So the human expertise would come into kind of design of that function mapper. Data and examples would kind of be used to kind of tune the parameters of that function mapper. And then we would have an output label space, right? So now you see human expertise is being used in features and function mapper. And because of that, there could be a trade-off between these two. So if we had more complex features, then we need the function mapper to be, more less complex, depending on what features it's trying to support. If the features are really good, then we don't need the function mapper to be too complex. If the features are general, then we need that function mapper. But the problem here is that we are trying to build a learning system which is data driven, but then we are still kind of interfering and are bringing in a lot of human expertise here. And then this is good when we have less amounts of data. But then as we move to large models, data driven large models, we will provide only limited human expertise. And then the models are deep and large. And then you have the input signal space and output label space. And then what it is actually taking in is lots of data and examples. So you see the switch between data and examples and human expertise. So we are providing limited human expertise, but then lots of data and examples here, right? So this is probably where we are right now in terms of production. So wherein we have lots of data with limited human expertise. The advantages of this system. So what are the advantages of this kind of a data-driven expert systems? We have full control over what features we use, full control over what function mapping we are trying to use. And then with enough data and examples, we'll be able to kind of do this task at a level probably human beings are able to do it. But then we are limited to specific tasks because we are not fully using the capabilities of the system here, because we are still kind of saying what features to use and how to map it correctly. Here, we are kind of largely relying on data to kind of form these models. With limited human expertise, we still have to put in some bit of expertise to understand why something is not working and then how to design these large models and so on and so forth. But then the heavy lifting is done largely by the data when it comes to learning, right? And then, I mean, this is where I think we start kind of not to tweak too much of the architecture and then not kind of make it over engineering the system. And then none of those things are being done here. Right? That's basically data-driven large models that we have currently. And where are we actually going now? So, I mean, in terms of, at least in the industry, we are going towards data-driven foundation models now, which are driving fine-tuned applications. So here we are still building specific machine learning models for specific applications. So if you take speech recognition as a problem to solve, you would build one large system which would do all of these things. So take the input space, there's a large model, then lots of data to provide some human expertise, then map it to output space, right? Whereas currently, where we are moving, which I'll talk about in challenges as well, wherein we are starting from an input space, then we are trying to kind of get to an intermediate representation or a feature or an embedding. This also is typically learned and then optimized. Then we kind of start actually also in parallel with huge amount of multimodal data. Multimodal is the keyword here. So wherein we are trying to kind of bring in different modalities together, text, speech, audio, images, and then probably sensor data, whatnot, everything that we could get our hands on, for example. And then build what are foundation models. So foundation models are essentially things that are not task specific, but then they kind of are trying to build an internal representation. And then those models are used to fine tune another a specific model, which is to be suited for a specific application. So the foundation model could be an audio foundation model, which kind of gives us an intermediate representation. I think this arrow that you see from foundation models will also go into the representation. I think I missed an arrow here. So the foundation models will also help us to arrive at a representation sometimes. And then at the same time, it will also help us to fine tune models for a specific application. And then the other important aspect here is we are also going to provide some kind of a context to the model, to the fine-tuned model, and which is also called prompt, for example, in the LLM world, right? And then so now we are bringing several things here. So we start with lots of multimodal data. We build foundation models, which are not task specific, but then they kind of try to arrive at some kind of an intermediate set of representation. Then we could use that to fine-tune a machine learning model, which kind of solves a particular task, right? So that is for a particular application. That's where we are currently, right? So you see, from starting all the way from human expertise, we started relying a lot more on data, much more on data, and then many more on data. Whereas we are trying to kind of change architectures in such a way that we are trying to build so lots of data-driven large models which are generic enough, and then we fine-tune it to a specific application. So right, this is like an approach which kind of has worked in the past, and then that's where I think a lot of our work is going on. So, right, let's look at challenges, which are also opportunities, correct? So challenges are always opportunities. They provide opportunities. So what are the challenges in the industry when it comes to machine learning, right? So the biggest challenge is the scale. So the scale at which we operate and build machine learning systems, it's huge, because a lot of these are data driven, and then there is an explosion of data in the last couple of a decade or so. What that meant has, how do we kind of build and then scale machine learning systems? That's a very important challenge, and then a very big opportunity in the industry around that, right? The scale actually automatically includes data. And then when we say data, it's both quality and the quantity, right? I mean, so quality includes, is it well labeled? And then is it clean enough? And then is it actually kind of representing the underlying phenomena accurately? And then how much of this data can we use across different tasks of machine learning that we are trying to solve, and so on and so forth, right? So those are the quality aspects. Then the quantity, of course, is more the better, but then of course, quantity without quality is not useful. So we are looking at lots of data to scale our machine learning systems, and then the systems are also quite large, right? So those are the challenges that we are trying to solve. And with data, the questions of how do we kind of arrive at labels? What are the methods that I can use to kind of, so typically, right? I mean, there's a lot of data that gets generated, but not all of it can be directly used, because typically machine learning systems require data to be labeled, for example, right? So that is not available all the time. So how do we kind of use unlabeled data, right? That's a big challenge. And then how do we kind of use different kinds of data, which comes into so many different kind of quality and quantity? How do we kind of use that? That's a big challenge, right? The third one is real world impact. I think this is sort of easier to define in the industry, because this could be built for specific applications, and then we have real users who kind of use the systems and then provide us the feedback, right? And then so there is a real world impact in that sense. But then the challenge is to actually make that real world impact from the perspective of like it being very accurate and then it being very useful for specific applications. Currently, that's still not the case. There is a lot of reliance on, I mean, so the real world impact is still kind of to be kind of seen much more accurately. The other big challenge that we are trying to solve currently in the industry is multimodality, which is to, I mean, an example could be how do we combine video, audio, text, speech, and probably sensor data, all of it together for so many different modes of our communication, and then put them all together into machine learning systems that can understand multimodal systems. So it's almost like so when we imagine interacting with a human being, for example, right? So there is a lot of, the human being comes with a lot of senses. So different kinds of modalities that the human being can kind of perceive, put them all together, make sense out of that whole different modalities of data, and then kind of help us with inference of different aspects and have interaction, right? So how do we bring that? So it's not at all clear. That's a very big challenge and opportunity currently. The last one, of course, is not something I am an expert on, but again, I just put it out here, which is to do with ethics and privacy. These are, I think, how do we kind of, when we have access to a lot of private data, and then how do we kind of build our machine learning systems around that? To kind of preserve that privacy of users, and then also the data, right? And then ethics is what are the problems that we should be solving with machine learning? How do we ensure that the machine learning problem that we are solving does not lead to more problems elsewhere? So those are the problems discussed there. And then this is again a challenging problem. There is a lot of work around ML ethics, right? And then what is possible? How do we design policies, for example? How do we maintain privacy and things like that? So these are big challenges. So in each, if you see, there are opportunities. So if you want to build machine learning systems at scale, there are opportunities. If you want to kind of use lots and lots of data in terms of, or build quality data sets to be used, there are challenges. Then there is in terms of achieving a real world impact over different applications, that's a challenge and opportunity. Multimodal signals, how do we integrate them? Lots of opportunities there. Ethics and privacy, there's a lot of work around that. And then there are lots of opportunities there as well, right? Yeah, now among those, right? So let's look at what are the challenges that India use case can solve. So this is essentially to understand what are the things that we could build in machine learning in the industry in India, right? So it's clear that we live in a multilingual, multicultural society, right? So what that automatically means is that's probably the closest way to define India, right? So there is a lot of interaction, there's a lot of data, and there's a lot of applications that are generated in such a multicultural, multilingual society that could use machine learning applications. And again, I mean, most of my work has been with speech and language, music, and music. So I'm just going to sample some challenges here, right? So as India, right? I mean, like, so there's a lot of, so let's start with data here, right? So there is a lot of data that gets generated within India currently, right? And for India use cases, because so there is a lot of opportunity with respect to using that. And then, so what is missing, of course, the challenge is the quality of that data. Quality of that data is mainly because of like the way like the data gets generated and then shared, for example. To give you an example, right? So take the example of speech and language. So that's one area I closely work on, for example, right? So the two big challenges there are how do we kind of handle code mixing and code switching? So in India, we do have bi and trilingual speakers. So typically, like say schools in the south, they teach 3 languages in school, whereas schools in other parts of India, they at least teach 2 languages. So most of the time, we learn Hindi plus English, or Hindi English plus another language from the south, say Kannada, for example, right? So what that means is a lot of Indians, again, not everyone, right? Are very well versed with mixing code. Mixing code means the sense of they switch between languages very, seamlessly. So they mix code. Code mixing means you are talking in neither in Hindi or nor in English, but English. That's code mixing. Code switching is when we kind of have two languages in a conversation, keep switching between the two languages, which seamlessly, right? So this is a big challenge, which is very kind of not very unique to India, but then the scale of this is so big in India that it requires specific applications, approaches to solve, right? And then the second big thing is under-resourced languages, right? So not all languages in India, for example, have the same kind of presence in the country, right? So take Hindi, for example, it has 500 million plus users, first language and second language included, for example. Whereas lots of other languages have 10 to 50 to 100 million users. Whereas there is a huge long tail of languages which have, I mean, there are certain languages which only have a few thousand speakers, right? So now you see huge distribution of these languages, and then how do we build speech and language technologies through machine learning for such a vast country where there is so much diversity in terms of speech and language, right? So that's a big challenge for India. If you kind of look at music, for example, we have a huge variety of folk art and film music in India, which has sophisticated structures. So how do we analyze them? So there's a lot of challenges associated there, right? So if you say these are sampling of challenges, but then if you just go now and then look at where machine learning is being applied in India, you see a plethora of places where it's being applied, right? I mean, if you see, there's a lot of machine learning in, say, every Uber ride you take or every kind of insurance policy you buy, there is some bit of machine learning that is going on behind. Or if you order on Amazon, for example, there's a lot of machine learning, or use Google services, Google Maps, there are machine learning problems there which are India specific that are being solved in each of these. So there is a lot of opportunity in India currently with respect to all of these things. Yeah. So this was like a broad set of like overview on challenges and opportunities, right? So each of these challenge comes with an opportunity associated, right? So that's how we see this. So let's kind of quickly look at how a machine learning workflow in the industry looks like, right? And then I'll contrast that with academia. So maybe let's start with academia so that it's easier, right? So in the academia, we start by identifying a research problem that we want to solve. It could be in a particular domain. Say I want to kind of work on speech and I want to work on automatic speech recognition, say. Then we do a large literature survey and just trying to understand what approaches have been tried and then how they've been tried, how they've worked, and then what data sets they've used, and then all those experimentations that they've done, right? Then based on that, we kind of try to propose some methods that we try to solve a particular problem. Then we collect data if it's not available, experiment, and then once the experiments are have some insights, we go and then publish. This is typically the workflow, right? So in the industry, it's slightly different, of course. I mean, wherein we are trying to work always backwards from the customer needs, right? So we first identify the customer needs, but then translate that to business needs, then translate that to machine learning needs. So not every customer need will need a machine learning solution, right? Then we work backwards from that machine learning needs and the goals, right? Then we propose solutions. These solutions in the academia need to be novel because that's one we want to push the research area. Whereas it's not necessary for a solution in the industry to be novel. So novel from a technology perspective is not a necessity. Then we gather and scale data. So as soon as we say scale data, scaling comes with its own set of challenges, and then we have to work through that and then build engineering solutions that could help us to scale the problem directly. Then we do experimenting and prototyping, and then which also provides us opportunity to publish and patent optionally, right? Then that prototype is experimented with, we iterate a lot, then we arrive at a system that works, then we put it into production. And once it's production, people in the real world use it, and then we use the feedback that we get from the users directly, implicitly or explicitly, and then we iterate on that and then produce improvements. You see, let's see kind of, so you see that's the basic difference in workflows. So if I were to just contrast them, right? So academia is working usually forwards, then look at ahead of what they want to do and then keep moving, going ahead. Whereas industry always work backwards from customers, right? So that's an important distinction to understand. And academia is usually technology focused. I want to kind of build new technology and then move forward. Industry is always solution focused. We want to solve problems for customers, right? And then innovation in academia is largely in the form of new technology, new methods, and new data sets, for example. Whereas innovation in the industry is multidimensional. It could even be a process change. right? How we train a particular model could be different, and then that could give us a lot of improvements as well. That's also valuable, right? And then academia typically is for the public good, right? The purpose is for the public good. This is in general, nothing to do with specific to machine learning, but industry is for customer benefit. So the approach to problems are going to be very different, right? And in academia, typically collaborations are across smaller teams. But in the industry, we collaborate across large internal teams from different domains, right? So we need not always that we work on people with who have machine learning background. So there are large internal teams that we have to collaborate with to kind of bring things to production. And academia, we publish and disseminate. That's the purpose. We kind of write papers, and then we talk about how do we kind of present this work in different venues and so on and so forth. Whereas industry's focus is mostly on building and commercializing things, right? And there is, I don't like this term explorers and settlers too much, but then it has been used in the past. So academia is typically for explorers, so wherein you are trying to explore new things, and industry is for settlers, so wherein you are trying to make things more efficient, build it, scale it up further when already something has been explored, right? Again, of course, these boundaries are no longer separable by a single hyperplane. So there is a lot of overlap now. This academia is getting into building and commercializing, and then looking at kind of how do we kind of innovate, and then how do we kind of collaborate across large teams through open source collaborations. And industry, again, is also kind of exploring a lot of new technologies, right? I mean, if you see, industry also writes a lot of papers. There's a lot of innovation in terms of new technology that's also coming out of industry, right? So there is a lot of overlap here. And then, I mean, if you see this kind of provides a good opportunity to collaborate as well, like wherein we could bring in the expertise and then the forward-looking agenda for academia, and like some kind of a working backwards agenda for the industry, and then have that sweet spot wherein there is a lot of exploitation of the technology that we're building, but at the same time we are also pushing further on the fundamentals of machine learning here, so that we could continue to kind of innovate further in all multi-dimensionals, different set of dimensions, right? Okay, so this, like, so what are the current topics that are kind of quite kind of getting a lot of attention in the industry? So one is foundation modeling, right? How do we build foundation models? These are general purpose machine learning systems that kind of take in an input representation and then input space, and typically give out a representation that could be used for further downstream processing, right? To build machine learning models for a particular application, right? So that's one area, right? And I think I talked about this in a little bit briefly already. And the second one is multimodality. How do we kind of bring different modalities together, like speech, text, audio, uh, sensor data? How do we kind of bring images, for example, and video, all of that together, and then achieve tasks that are multimodal in nature? So the response need not always be text. It could be a combination of text plus video, which is the way I think a lot of human beings interact as well, right? Yeah. And the third one is large scale models. How do we scale up these models further so that we can actually build large scale models that are efficient, right? I put efficient ML later. The next one is privacy and regulation. There's a lot of work around this to ensure user privacy, and then regulating these machine learning systems so that they could be used in the most I mean, ethical way as possible, and also to ensure that it's not kind of giving false information. It's not spreading things that should, and then it is not it's not affecting any of our the social fabric of the society. And then the other big area is Edge ML. So Edge ML talks about doing machine learning on the edge, so which is essentially the device that we hold. This could be contrasted with Cloud ML. So Cloud ML would mean that we can have large models. We don't have a lot of like restrictions on compute. Whereas in Edge ML, there's a lot of restriction on the amount of compute that is available, but it's quite private. Like they think such as a car, right? I mean, a car has limited compute power. So if you want to deploy a machine learning system on the car, in the car, then we need to kind of look at technologies that can help us do that. It's the topic of HML. Right? Domain expansion. This is again something we see everywhere, right? This talks in general about all the different domains where we are trying to extend machine learning into. Again, there's a bit of caveat here, which is what is being called as machine learning is a lot of times just some form of a regression or some kind of learning based on some rules, but then adapted with some little bit of data, right? I mean, it still could be called machine learning, but not in the traditional sense of the word. It's not machine learning in that sense of the word. Right, so many different domains are applying machine learning, so including like areas where the traditionally machine learning was not used. So nowadays we do see machine learning being applied to kind of detect faults, and then, for example, in metals, for example, very different set of applications that are being expanded into, right? So wherever there is data available, we do see machine learning being applied. Whether or not it's relevant is it's a slightly a different discussion, but right. And as I said, efficient ML, as you see, the current models, they are quite large, and then which means that they consume a lot of resources for inference. So how do we make it efficient? Smaller models to kind of achieve the same tasks. The last one I think is probably every one of you is aware is generative modeling. I think this is where I think we use machine learning systems to kind of provide us with specific solutions and answers through multiple modalities of interaction, right? I mean, this is where I think generative AI is kind of getting a lot of popularity as well. And then, I mean, they're quite useful models, like, of course, as long as they are used in the specific way it is intended to, or it's designed to, right? Right. These are the topics. Where are we actually heading to? Again, this is very speculative. This is my opinion only. Could be very wrong from where I stand right now. So we are tending towards artificial general intelligence. So what that actually means is to be defined better. I do not see that to be having a single definition right now. But then as we move further, it starts getting a lot more clearer, and then probably it's not going to be like a flip of a switch, wherein we say we do not have AGI today, we have AGI tomorrow. Not going to happen. But then over a period of time, we are looking at building AGI systems. What AGI systems here talk about is machine learning systems that are general, that have general capabilities, in the sense of they can work on a different set of tasks without actually having to do a lot of context switch. That's typically a lot of human beings, right? We can do several tasks without a lot of, context switching. Second big thing is contextual ML. This could be personalizing the models that are being built for specific people, specific populations, specific use cases, and specialized applications, right? So providing a context helps build specialized applications, which needs a lot of context to understand what's happening. So if you want to build a machine learning systems, providing a lot of context to understand the culture in which that particular music is performed, helps us to build a lot of, helps us to kind of make the machine learning system better. Third one I see is ML as a service. So wherein I think this is already there in place, it is going to get better, wherein like we kind of have large models hosted somewhere, and then we could use that to kind of get our tasks done. So this could be, for example, the ChatGPT is like some kind of an ML as a service, right? So you kind of can subscribe to that, you can ask questions, and then it'll respond. Or it could be things such as, say, AWS Transcribe, for example, or Google also has Translate, right? So these are services but being offered as machine learning system offered as service. There's also some focus on improved regulation for the use of data. Again, not an expert, but this is one place where there's a lot of chatter going on. Then generative models are getting better and better. They have huge problem with hallucinations currently, but then they're going to be getting better. Then this is something I kind of anticipate that we'll still do a comeback towards small models, which are made very specific to some small set of applications, especially in the case of edge modeling, right? Edge ML, where we need to deploy smaller models, which are way more efficient, and then they can still solve a specific use case, but they are not general enough. So that's still okay. And in terms of applications, there's a lot of work around the next 1 billion users in India, right? I think Google had a big initiative around this. And then essentially so we are building machine learning systems that can scale to the next 1 billion users, which is typically the way they approach the use case of India. How do we build for India? How do we build machine learning systems, machine learning solutions for India? right? And as we are doing that, hopefully, I also hope that in the industry, from the industry perspective, there's also a bit of focus on accessibility and broader reach, so that it reaches a large amount of population, which is also which can also benefit from all the trends that are happening currently, right? Okay, so just to kind of this was just my perspective on how the industry is moving and in terms of building machine learning systems. So now that we have that kind of a perspective, how do we actually prepare for a career in the industry with respect to machine learning, right? Right. I mean, again, I would, this is personal opinion. This based on lots of hiring that I do with Amazon, and then also interacting with several people outside in terms of what is it that we should be looking for if you are doing your master's or a PhD and you're looking for a career in the industry. This is some kind of a set of guidelines that you could use to kind of see if industry jobs are suitable for you and how do you prepare for that, right? So broadly, I would say you would need to kind of understand several aspects of machine learning, which includes ML breadth, ML depth, ML problem solving, and building end-to-end ML systems, right? Uh, right. So ML breadth talks about, are we able to kind of understand different machine learning techniques and then arrive at the links between them? How is a particular technique formulated, and then how is it similar to a different technique, and then borrowing across different domains, right? So this particular technique applied in computer vision, how does it apply to, say, speech, for example, right? So that's the ML breadth. So we have a broad canvas over which we understand different methods that have been proposed, and then different kind of approaches that have been taken to solve problems. And then, so we have that breadth of knowledge across different domains and different fields and different techniques, right? But then breadth itself is not usually sufficient, because typically we solve a particular problem, which is going to be ML depth. So we need a lot of depth in one particular area, and then each of the methods that we kind of understand through breadth need to go deeper, understand its theoretical fundamentals, theoretical backing, when does it work, when does it not work, and so on and so forth. With those two arms, we can actually go towards ML problem solving, wherein problem solving here talks about, given a problem, how do I apply a machine learning based solution to that? How do I identify what data we need, what experiments to do, and then how do I evaluate that system? And then once we have this understanding, we can build an end-to-end ML system, where like we start with a problem. We are able to understand why it needs machine learning, explain that, what kind of machine learning systems, models you need to build, and then how do we get the data for that? How do we evaluate that? What are the experiments we done? And then how do we prototype it so that it could be tested out in real world, and then put it to production, wherein it will be used by a large number of users, right? For all of these, we need very strong fundamentals. So this is something that I cannot emphasize enough. Very good fundamentals in probability theory and linear algebra. And essentially, these two are the mathematical foundation for most of the statistical learning we do. And then, of course, we do need some domain knowledge with respect to specific areas if you are going to work on a specific area, right? So that's the theoretical fundamentals, right? Then we also need very good hands-on experience with machine learning tools and techniques. And most importantly, when would you use a particular tool and when would you use a particular technique, right? So that's again important because these are the things that we look for. So so the machine learning depth, breadth, and problem solving helps us to kind of build that expertise. Then there is a lot of hands-on work to do with respect to end-to-end machine ML system building. Then all of that needs to be backed up with fundamentals in both theory and fundamentals in practice, which is to use the specific right set of tools for and techniques for the right set of problems, right? And understand all the trade-offs involved. And then that kind of gives you that preparation, right? But basically, so if you're looking for a long-term research career in the industry, we should be looking at being a builder of the tools rather than the user of the tools. So it's not just sufficient if we understand how to kind of, say, build a neural network-based system or a classifier. We need to understand how we actually build that from scratch, not just use it in our work, right? So that's how we grow. I mean, this is basically what I see to be a set of like things to watch out for when you are looking for a career in the industry, right? So that's mostly what I wanted to talk about. Yeah.
Thank you so much, Ajay, for giving your time. I think it was really nice interacting with you and all the points that you told. Uh, thanks again. So thanks all the participants. So see you.
Thank you so much thank you for the invitation. Thank you, Vipul. Yeah. All right. So please feel free to write to me in
Thanks,
case you have
Ajay.
questions, or I'll be happy to kind of engage in further discussions. Thank you.